Hi, this is a brief review for the 1D kinematics test, and that will cover frames of reference, acceleration and velocity, concept questions, and calculations. The kinematics equations, lots of problems with kinematics equations. Free-for-all problems, which is just a subset of kinematics equation stuff, and interpreting motion graphs. First off, frames of reference. A frame of reference is a framework used for making observations and measurements. We usually use the Earth, so it's what we are measuring velocity and position with respect to. And generally, if you're going 20 meters per second, you're going 20 meters per second with respect to the ground, which is not moving. Relative to you, it's not moving. We represent it in a problem often with a coordinate system. If you're walking from the back of a ship to the front, what would you probably use as your frame of reference? Well, if you're on a ship and you're walking from the back of the ship to the front, you're probably going to want to use the ship as your frame of reference. So if you say you're moving 2 meters per second when you're on a ship, you mean relative to the ship, not relative to the water and not relative to the person who might be standing on the ground, because your movement relative to this person over here would include the ship's movement as well as yours. So you would probably use the thing that is stationary with respect to you, which would be the ship. If you're walking from the back of a train to the front with a speed of 2 meters per second and the train is moving 40 meters per second, what's your speed relative to the train? Well, relative to the train, it's 2 meters per second. What's your speed relative to the Earth? Well, if you're on a train, let's say you're on top of it because that's easier to draw, and the train is moving this way 40 meters per second, and you're moving this way 2 meters per second, somebody out here would see you moving with both the train's velocity and yours. So this person would see you move 42 meters per second. And if you were walking to the rear of the train, then your speed would actually be minus 2 meters per second, and they would see you walking 38 meters per second. Distance is a scalar quantity. It is measured in meters. It's always positive. Displacement, on the other hand, is a vector quantity. The direction of it matters. It is also measured in meters. And it's going to have either a positive or negative sign. Okay, sometimes we just say 3 meters and not positive 3 meters. But if you're on a test and you're asked which of the following can be a displacement, it needs a sign to indicate the direction. Displacement is a change in position. And this Greek letter delta means change in. And it always means the second value, the final value minus the initial value. We can have a delta v for velocity, and that's going to be the final velocity minus the initial velocity. So that's what delta means. And so a change in position, how far the ending point is from the beginning point, is your displacement. Distance is the total, like all of your steps. So like if I go to the Y and I walk 3.5 miles and get back to my car, my distance is 3.5 miles, but my displacement is 0 because my ending position and my initial position are the same. So no displacement, but my distance is all of my steps no matter what direction I'm traveling in, and so that would be 3.5 miles. So this is an example like you might see on a quiz or a test. Given that A is at 1 meters, let's say here is 0. A is at 1 meter. B is at 15 meters. C is at minus 30 meters. D is at minus 20 meters. E is at 10 meters. And F is at 5 meters. You may be asked, given information like this, and asked to find the distance from A to E or the displacement from A to E. And if you're finding the distance from A to E, it's as you have to go from A, B, C, D, and then E. Okay, so from A to B, if A is at 1 meter, then from A to B is No, this is a mistake. A is at 0 meters. I thought that was a little weird. So A is here, not there. Sorry. So from A to B would be 15 meters, from 0 to 15. From B to C, remember this is distance, it's just how far. So from B to C, from 15 all the way to minus 30, well, that's 45 meters. From C to D, that would be from minus 30 to minus 20, well, that's 10 meters. And then from D to E, well, it's going to be 20 meters from D to 0 to A, and then 10 more, which gives you a total of 30. And so if I want my distance, I add all of these up. 5 and 5 is 10, carry my 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 100 meters. So if I walk from A to E, alphabetically, A, B, C, D, E, then this is my distance, but my displacement is quite different. My displacement from A to E is simply how far it is from my beginning point to my ending point. And in this case, the displacement is going to be 10 meters to the right or east. If east and west is the designation, then it would be east. If it's left and right, then to the right. So notice the distance did not have a direction on it. The displacement does. Displacement is simply how far from the beginning point to the ending point. Distance, you have to add up all the points. Speed is a scalar quantity, and it depends on distance. It is measured in meters, and it is always positive. Velocity is a vector quantity. It depends on the displacement. It is also measured in meters, and it must have a sign, either a positive or negative. Velocity is the change in position over time, or distance divided by time. Technically, it is the final position minus the initial position over the final time minus the initial time. Initial time is almost always 0, so just over a time interval. So practicing a little bit, find the time required to travel 20 meters at 4 seconds. Well, is this a distance? 4 meters per second. There's a velocity. If our equation is velocity is distance over time, if I want a time is equal to distance divided by velocity. And so that's going to be 20 meters divided by 4 meters per second. And that's going to be 5 seconds. How far will you travel at 3 meters per second for 6 seconds? So again, using this equation, distance is equal to velocity times time. And so that's 3 meters per second times 6 seconds, or 18 meters. And how fast are you going if you travel 20 meters in 5 seconds? Velocity is distance over time. So 20 meters in 5 seconds equals 4 meters per second. So those are some examples of using the simple velocity formula. Acceleration is the rate of change in velocity, or a change in velocity over time. If I rearrange this equation, I get the final velocity is the initial velocity plus acceleration times time. Let me prove that to you really quick. Acceleration is a change in velocity, so that'll be a final velocity minus an initial velocity over time. If I multiply both sides by time, I get an AT over here equals final velocity minus initial velocity. And if I add initial velocity to both sides, I get this formula right there. So that's not anything new. That's the definition of acceleration, basically. Having a positive acceleration does not necessarily mean you're speeding up, and having a negative acceleration does not necessarily mean you're slowing down. The important thing is, how does the velocity and direction compare to the acceleration direction? And if your velocity and acceleration are in the same direction, then you speed up. And if your velocity and acceleration are in opposite directions, then you slow down. So it's not any one of the directions, it's how they are together. Acceleration in the same direction speeds you up. Acceleration in an opposite direction to what you're going in will slow you down. If an object changes speed from 10 meters per second to 5 meters per second in 2 seconds, find the acceleration. Acceleration is a change in velocity, the final minus the initial, over time. So that's -5 over 2 is -2.5 meters per second squared. And that's, oops, I skipped this little part. What are the units of acceleration? Meters per second squared. Meters in the top, second squared in the bottom. If an object has a velocity of 4 meters per second and accelerates at 2 meters per second squared for 3 seconds, what's the final velocity? Using the equation at top, final velocity is initial velocity plus acceleration times time. The initial velocity is 4 meters per second. Acceleration is 2 meters per second squared, and the time is 3 seconds. So I get a 6 from this, and it's meters per second because the seconds canceled and I had those meters, plus 4 meters per second. The final velocity would be 10 meters per second. Okay, there are 4 kinematics equations that you need to know how to use, and they're all listed here. This is, I just copied this from the course content, so you've seen this before. Velocity, final velocity is initial velocity plus acceleration times time. Final position is initial position plus 1/2 times the sum of the final and initial velocities times time. The one without any subscript, that's the final. So 0 is initial, without a subscript is final. Final position is initial position plus initial velocity times time plus 1/2 at squared, acceleration times time squared. And the final velocity squared equals the initial velocity squared plus 2a times the change in position. You may see these with different subscripts. I actually might write them with different subscripts in my examples later. But these are your 4 basic kinematics equations. In order to solve them, and this is important, you must have 3 of the 4 variables in order to solve a particular equation. And you choose the equation that you're using based on the 3 variables that you have. You cannot use this equation to solve for initial velocity if you don't have time. But you can use this one to solve for initial velocity if you don't have time, if you have position instead. So you choose your equation based on what you're looking for and what you have. Example 1, an object starts at rest and moves, okay, so that's an initial velocity of 0, and moves to the right for 3 seconds, that's a time, with an acceleration of 4 meters per second. How fast is it moving? So we're looking for a final velocity. So I'm going to use the final velocity is the initial velocity plus acceleration times time, because that's what I have. So our initial velocity is 0, and our acceleration is 4 meters per second squared, and the time is 3 seconds. And so the final velocity is 12 meters per second. Okay, free fall. Free fall is I think I missed on a previous slide. Free fall is an example of what was on this slide. Here we go. Remember that free fall is just a special case of accelerated motion. The only force acting is gravity. The acceleration is not an unknown. It's not a variable anymore. It's -9.8 meters per second squared. There is only acceleration in the y direction. There is no x acceleration in free fall problems. Gravity is the only thing acting, and it only acts downward. So all of these same kinematics equations work in free fall problems, except everywhere there's an acceleration, you know the value is -9.8 meters per second squared. And that value, the acceleration due to gravity, the symbol for it is lowercase g. So all of these accelerations would become g's. Okay, so an object falls for 3 seconds. How fast is it moving? And so final velocity is the initial velocity plus gravitational acceleration times time. And the initial velocity is 0. If it falls, it's assumed to fall from rest. And so the final velocity is -9.8 meters per second squared times 3 seconds. And that's -29.4 meters per second. So free fall problems aren't any different than regular acceleration problems. We just know what the acceleration is. An object moving with a velocity of 5 meters per second with an acceleration of -2 meters per second squared. How long will it take to reach a velocity of -10? So we have Vf equals Vi plus At, and we're looking for time. We've got the final velocity. Okay, so Vf minus Vi equals At, and so if I divide both sides by A, the time will be the change in velocities divided by acceleration. So the final velocity is -10 meters per second. The initial velocity is +5, but that minus comes from the equation. And divided by the acceleration, which is -2. -10 minus 5 is -15, divided by -2 equals -7.5 seconds. A similar free fall problem, an object is thrown upward with a velocity of 50 meters per second. How long will it take to reach a velocity of -60? Okay, so using this same equation, solving for time, so I'm going to use this equation. The final velocity is -60 meters per second. The initial velocity is 50. The acceleration, I'm going to cheat here just a little bit. G is -9.8, but that's really close to -10, so we can do some estimation with 10. So instead of pulling out my calculator, which I did not bring here with me, I'm just going to say G is about -10. So that's -110, right, divided by -10, which is a +11 seconds. An object has an initial velocity of 2 meters per second. It accelerates at 4 meters per second squared for 3 seconds. How far will it travel? Okay, so we have that equation that says that our final position is our initial position plus our initial velocity times time plus 1/2 AT squared. And so this is 0. So how far will be the initial velocity, 2 meters per second times the time, which is 3, plus 1/2 times the acceleration, which is 4, and the time squared, 3 squared. 2 times 3, this is going to give me a 6 meters, and 3 squared is 9. 9 times 4 is 36, and half of 36 is 18, and 6 meters and 18 meters is 24 meters. An object has an initial velocity of 2 meters per second and accelerates at 4 meters per second squared for a distance of 10 meters. What's the final velocity? Well, we have that equation that said that our final velocity squared equals the initial velocity squared plus 2a, I think it was delta x. So our initial velocity squared, that's 2 squared plus 2 times 4 times 10 meters. That's 2a and your distance. So 2 squared is 4. 2 times 4 is 8 times 10 is 80. So the square of our final velocity is 84. And to solve for that, I have to take the square root of both sides, and I get the final velocity is about 9.2 meters per second. Some problems require 2 steps. Given an initial velocity of 3 meters per second and a final velocity of 15 meters per second and a time of 4 seconds, find the distance traveled. Well, in order to solve for this, I need acceleration first. So acceleration is that change in velocity over time. So that's going to be 15 minus 3 over 4 seconds. 15 minus 3 is 12 over 4. So I get a 3 meters per second squared. And now I have acceleration as well as initial and final velocity and time. And if I need the distance traveled, well, let's see. I can use Vf squared equals Vi squared plus 2AD to solve for that distance. VF squared minus VI squared divided by 2A will give me my distance. It's not the only way to do it, but it's the one that jumped out at me. So the final velocity squared, 15 squared is 225, minus the initial velocity, which would be 9, divided by 2 times that acceleration. So 225 minus 9, I get 216, divided by 6 equals, I get a distance of 36 meters. A little more free fall, an object falls from a height of 10 meters. How fast is it going at the bottom? I can use this same equation again. So VF squared equals VI squared plus 2, in this case, GD. And the initial velocity is 0. So VF squared equals 2 times, I'm going to use 10 again for G, and the height is 10 meters. But it's negative because you're falling from here in a negative direction. So you're going to go from 0 down to negative 10 meters. And so 10 times 10 is 100, positive 100, times 2 is 200. And then if I take the square root of 200, I get about 14.1 meters per second. Okay, quickly let's go over the stuff that you need to know about motion graphs. On a displacement versus time graph, a position versus time graph, the slope is velocity. So if I wanted to know how fast it's going in this section, I would find the slope of that line. It's change in y, which would be 60, over change in x, which would be 10. 60 over 10, the velocity here would be a positive 6 meters per second. If it's flat, the velocity, the position is remaining constant, and so there is no velocity. If the slope is negative, then the velocity is a negative velocity. But you find the slope, again, the slope just comes out to be negative. The area under a displacement time graph does not have any meaning, so you'd never find the area under a displacement versus time graph. Velocity versus time graph, the slope is acceleration, so just find the slope. In this case, it's the same numbers, and so the acceleration is 6 meters per second squared in that portion right there. Because instead of the y units being meters, they're meters per second. So it's meters per second divided by seconds to get that slope. The area under the curve, the area between the curve and the axis for a velocity time graph is displacement. This would be a positive displacement, and this would be a negative displacement. Acceleration graphs, the area under the curve is a change in velocity. The slope of an acceleration graph time is not useful. Again, velocity versus time, slope is acceleration, the area under the curve is displacement. And that might be, no, acceleration versus time, the area under the curve is change in velocity, the slope is beyond the scope of this course. And that is all I got to say about that. I hope this was helpful as you prepare for the one-dimensional kinematics test. Good luck.